All right, let's look at some examples of what you're going to be doing in your homework to see how all of this plays together. Here we have a problem that says name two rays that contain the following line segments. So here we have part A says select two rays that contain TU, the line segment TU. Okay, well, our line segment TU, let's just kind of mark that for a second. That would go from here to here. There's TU. So anything along that line we could use to name um, that that ray that would contain that. So let's look at what they have here. They said ray TV is a possibility. Well, because ray TV would start here and go to here, so that would be a ray that would contain TU. We could also call the ray TU itself. That would be a possibility. Now we cannot call it UZ because UZ is a completely different ray. Likewise, SX over here is a completely different ray. And YV is this ray right here. That's a completely different ray. So we could only use these two. This one says select two rays that contain XZ. Well, XZ, let me use black, see if we can make this a little bit better here. XZ, it would be this segment right in here. So that's what we're looking for. We're looking for rays that will contain those 2 points, or that will at least talk about those 2 points. So our first one here is XY. So if I started here and use this ray, well, that would include that. ZU, that would be this ray here. That's a completely different line, so that wouldn't work. XT is this ray here, so that's a completely different line. That wouldn't work. And SY is this ray right here. Again, that's a completely different ray, and that won't work. So in this case, even though they told us to select two rays, there was only one possibility in the answers. So that's okay. Watch out for that sometimes. All right, now it says use a protractor to find the measure of each angle. And they have a protractor listed out for us here, so we just have to learn how to read it. So first of all, they want us to measure CAD. So CAD is this angle right here. So if we look at our protractor, and we always read it for starting here at this terminal side, so we would go up to 10, 20, 30, 40, 50, 60 degrees. So that would be a 60-degree angle. Let's look at the next one. GAB. G is here, A is here, and B is here. Well, this has kind of violated the rules of using our protractor. If we were going to measure this angle in reality, we would turn our protractor so that this AB was lying along this line right here, and we would be able to measure it easier. But that's not what's been given to us. So we have to figure out another way to be able to figure out what that angle measurement is. So let's start off by going to the very far terminal side here, and that would be 160 degrees. And now then, if we were to take off this part right here, which is 20 degrees, then we would have a total measurement of 140 degrees, which is what they said it should be. So sometimes you may have to do a little bit of figuring out. Let's look at this one here. This measurement is FAB. So here we go, FAB. Here we're going to have the exact same thing. So we're going to have to figure out what is it all the way over to here, which looks like it's about 130 degrees. 130 minus, now let's figure out what it is to here, and that looks like 20 degrees. So if I subtract those, what's left in the middle then would be 110 degrees. And then finally, they're asking us for the measure of HAD. So HAD would be this measure right here. And again, if we could, we would move our protractor around so that we could see it better, but we don't have that luxury. So I'm going to measure what it would be to go all the way around to that terminal side, and that would be 180 degrees. And if I take off this part of it, then I'm just left with here in the middle. So this part of it looks like it was 60 degrees. So if I subtract that, I get 120 degrees. All right. Now for something really interesting. We're gonna now be using our algebra skills to be able to figure out what some angle measurements are. This one says find the relationship among marked angles in the the relationship. So sorry. The relationship among marked angles in the figure is the measure of angle AOB. So AOB, that's this angle right here, is 1/3 the measure of COD. So whatever COD is, let's call it X. This angle is 1/3 that amount. So it would be 1/3 of X. We can use that now to set up an algebraic equation. So we can say, well, 1/3 X plus 100 degrees plus X degrees. What do all of these add up to be? Well, that makes a nice straight line there, which is always 180 degrees. So if I add together my x's, 1/3 x plus 1x, I could change that into 3/3. So that would be 4/3 x plus 100 equals 180. If I subtract the 100 from both sides, we get 4/3 x equals 80. And then if I multiply both sides by 3/4, so that the left side would cancel out, we're left with x equals 80 times 3 divided by 4 is 60 degrees. So that tells us that this measurement here is a 60-degree angle, which is what we have, and that this measurement is 1/3 of that, which would make a 20-degree angle, which is what we have. And then finally, for our last example, this one looks a lot more complicated than it really is, especially if we understand the relationship between arcs and angle measurements. So here we have one that says in the figure below, A, which is this line here, and B, which is this line here, are parallel. That's what that notation means. And O here is the center of the circle. Complete parts A through E. So part A says they want to know the measure, that's what this notation means, the measure of arc BC. So arc BC would be the same thing as the measurement of that angle. So what is the measurement of that angle? 70 degrees. So that means that the measure of arc BC is 70 degrees. Next, they're asking us for the measurement of arc CD. So arc CD would be this arc right here. And again, it has to be the same amount as that angle measurement. So that angle measurement is 110. So is the arc. See how easy this is? The measure of arc AD. So arc AD is right here, it has to be the same as its interior angle. So that would be 70 degrees. Then we have the measure of arc AB, which is here AB. Again, it would have to be the same as its measure of interior angle, which is 110 degrees. And then finally, we have the measure of DAB. So DAB would be this arc. Now that's a major arc. Remember that terminology there. It would again be the same as its interior angle. Now this forms a nice straight line here because this is a diameter of our circle. So the measurement of that would be 110 plus 170, or 180 degrees.